All right, BradCooney.com, in association with HCN Networks, is honored to have on board retired NASA planetary scientist / physicist Philip Metzger. Philip, really appreciate you joining us. Very, very big news today in your world and in our world. Welcome to the show.
Thank you. Glad to be here.
Definitely an honor having you on board. Okay, so let's get into this. Today, NASA announced to the world that liquid water, they see it flowing on the surface of Mars. Talk about that. Talk about the implications of this.
Yeah, very big news. We've seen gullies forming on Mars for many years now with the spacecraft that we have in orbit. We would notice that there are gullies going down into the sides of canyons, and then during certain seasons of the Martian year, the gullies would change or new ones would form. And there's been a lot of discussion over the years over what physical processes could be causing this, because the Martian atmosphere is so thin that water would evaporate very quickly, and it shouldn't be able to run downhill to trickle down for such a long distance, creating these little gullies. So it's been suggested maybe it's just dry granular flow, just in the low gravity, maybe the granular materials flow better. And other people have said, well, maybe there is some kind of a salt in the water so it's a brine, and maybe the brine has properties where it can survive as a liquid for a longer amount of time before evaporating. And so that's what the discovery was announced today. They've explained the chemistry of the water and what kind of a brine it could be. They have observational data explaining it, showing it, and they have laboratory work that agrees with the observational data. And so they understand now that it's perchlorates that are in the water. It's a perchlorate brine, and that gives it the right properties so that it can be liquid at Martian conditions, and it can trickle down these hills and cause the things that we're seeing on the planet.
Wow, that's just mind blowing. Okay, so the significance here, as I see it, is now that we know that the liquid water can do this, even with the properties that it has. If we have a manned mission there, that's huge, right? Because they can use that to purify. They can use it to make oxygen and energy and all kinds of things, right?
Yeah, knowing that there's water that's not too far below the surface, it gives us it allows us to strategize how to use that water to build our missions around it. And water is the most valuable resource we can have on any planet, because we can use it for radiation shielding. It's one of the best materials, probably the second best material in nature for stopping radiation. The best material is liquid hydrogen, and where do you get that? You get it from water. So the top two materials are both come from water. Also, we use it for drinking. We use it for plant growth. If we're going to grow crops on Mars, you're going to need a lot of water. And you can use it to make rocket fuel. You can electrolyze the water to get hydrogen and oxygen. And then on Mars, we would probably use carbon dioxide from the atmosphere. We would crack that molecule to split the carbon and the oxygen, and then we would form the carbon and hydrogen together to make methane, and then we would liquefy the oxygen. And so the liquid methane and liquid oxygen would be the propellants we would want. So not just for drinking, but also for rocket propellant, for radiation shielding, water is really the best material that we can get in the Martian environment to make space flight more affordable and to make it more robust so that we can have more effective missions.
A lot of people want to know, when do you think we'll have boots on the ground, manned mission to Mars? Does something like this expedite that?
Well, I think it might, because it shows how interesting Mars is, and really the only thing we need to get to Mars is a steady budget. Mm-hmm. We know what we don't know. That's dangerous to say, actually. There's always things that we don't know. We're going to discover those along the way. But we've been thinking about Mars missions for a long time. We've been developing the plans. We've developed the architecture. And I was part of the road mapping team on this last go-round where NASA went into great detail describing all the technologies that we don't have yet. They're in the conceptual stage or they're in the early development stage, and we described how we need to get these technologies mature. So we think we know what we need to do to get the missions ready to go to Mars. The plan right now is to get to Mars in the 2030s, and we're on a pathway toward achieving that. As long as we can have steady budget and not be distracted from working on that goal, I think we can do it. Now, there's also private groups like Elon Musk, SpaceX. They want to get to Mars. They were aiming for the 2020s. I think that's a little ambitious. If they had been making a little bit faster progress on the technology, I think it was possible, but as time keeps ticking, it may be more likely that even SpaceX would not get there until the 2030s or later. Mars One, they say they're going to do their missions based on currently existing technologies. I don't believe those technologies really exist in a mature form, and I think it's too ambitious to say they're going to get there on their published timeline. But it's doable for sure. Any one of these groups could do it with adequate funding. It's not any magic required. We know how to do the engineering, and we just need to focus on it and get the technologies built.
Do we know how deep these water gullies are, like when the water's flowing? I read somewhere, we're pretty sure how long they are, but what about how deep the water is?
We don't know that. We know that, I'm sorry, I can't tell you the figure, but we know by looking at the sides of these canyons where the gullies are coming out, we can see the layers in the rock outcroppings, and we can see what layer they're coming from, and therefore we know how deep it is to the water. But the shape of these, if it's an aquifer, the shape of them, or whether or not they're all interconnected into some sort of an underground network, we really have no idea yet. It's going to take more exploration. We'll probably do a lot of that robotically. We need to get robots on Mars. We need to get them drilling down in, and also exploring the faces of these cliffs where the water is seeping out. And I think we're going to make a lot of progress by doing that. It's going to be a little bit tough because having a robot climb down the side of a cliff is new. But we can do that. I think by having a robot that rappels down on a tether, that might be an easy way to do it. So I'm sure that the folks at NASA and especially at JPL have some ideas on how to do that.
If there's a much larger abundance of this water underneath the surface of Mars, maybe in aquifers or even ocean size, like I guess in Europa, they're saying this. Europa might be have an ocean underneath its surface. How do we? The 2020 rover, I believe it has a radar maybe underneath it. Did I read that right? Where it can actually map where some of these water aquifers might be.
That's right. It's got a ground-penetrating radar on it, and so it will be looking at the subsurface, getting radar reflections and understanding the structure of the subsurface. But we've always known Mars has a lot of water. It's always a big deal when you can prove it with a robot on the surface, digging in and touching the water. But we know by looking at the polar caps of Mars that there's water. We can see it in the atmosphere, a very small amount. And you can see the scarring of the landscape from water in the past. It looks like there may have been an ocean along the northern part of Mars. And so I'm putting it all together. There's been a model that says most of the water is frozen under the surface. So you've got a region at the surface where the ground is rather dry, and then below that there's what we call the cryosphere, where it's frozen water. And then even deeper down, maybe kilometers down, is where it's warm enough and the water can be liquid. actually liquid water close to the surface, not just deep beneath the cryosphere, but also just a few meters down, and it's liquid because of the perchlorate chemistry. But we've always known that there is lots of water, mostly in the form of ice, on Mars. And so we've always had plans to dig down to it with robots, excavate chips of ice, and then bring it to processing plants where we can prepare it. It's just if we can drill down to the water and get it out by drilling instead of strip mining, that would be a lot easier.
Now, we have a rover that's still unbelievably is still working up there. It went up there with Opportunity, and now Spirit's still doing its thing. Is Spirit close enough to one of these things where it can maybe image some of these water aquifers?
I don't know. I heard some talk about it today on the press announcement. One of the rovers is close enough where it could visit one of those sites. But the problem is the rovers were not designed for driving on the steep slopes. And these slopes are loose material, so trying to drive in loose material, it's really too much of a risk. The robots probably couldn't get there, and if they did, there's too much of a risk of them getting stuck. So I'm sure people are assessing it. Maybe they can identify some one of these lineages that is more accessible than most.
But how cool would it be to get close enough to at least take some pictures of it?
That'd be very cool.
Oh, man.
But we are getting pictures from orbit. So we're getting pictures. What we really need to do is test the chemistry. We need to actually dig it up and put it into an oven and bake it and study the chemistry with mass spectrometers and other instruments. Yeah.
All right. My listeners would have my hide if I didn't ask you this question. Of course, you probably know it's coming. It's about the life question on Mars. So let's do the 1 to 10 scale. 1 being no life up there, and 10 being yes, definitely life up there. Where were you on this question, say, 10 years ago, and where are you now?
So there's definitely a lot of uncertainty, and so if I give you a number, the number is not really a measure of hard data. It's really a feeling of how am I guessing about it.
Right.
I would have put it over the past 10 years. I've been this entire time fairly confident that there's a good chance that there's life on Mars, and I would probably expect to find it deep under the cryosphere, down inside the liquid water, deep down, like miles down under the surface. And the reason I feel fairly confident that there is life on Mars, let me give you an analogy. So I live in Florida, and if you go out in Florida and dig a big hole in the ground, it will start filling in immediately with groundwater and rainwater, and then you'll have a pond. If you come back to that pond in 10 years, you can catch bass. And I always ask people, how did the bass get into the pond? Let me ask you, can you take a guess? How do you think bass would get into a pond like that?
Bird excrement?
Wow, that's a pretty good guess. It is birds that carry them, and they carry the eggs. Bass eggs will stick to duck feathers. And so the ducks flying from pond to pond actually carry the life in egg form.
Wow.
So we may think these ponds are isolated, but they're really not that isolated, and life has ways of hopping from place to place. Well, the same thing with planets. Earth and Mars are actually pretty close to each other, and tons of rocks have been passed back and forth between the two planets. When a big asteroid hits the Earth, it knocks out a ring of lightly shocked rocks from the spallation zone, and those rocks can carry life. And we can predict how many tons of Mars rock should end up on Mars. Earth rock should have ended up on Mars, and those rocks probably carry life. So the question is, when they get there, will the life find the chemistry that it needs to survive? And there's reason to believe that Mars may have been warm and wet in the past. There's still a lot of arguing over that point. but certainly there has been a lot of water activity on Mars in the deep past, and so it could be that there were conditions from time to time, or in various places, if not the entire planet, where life could have landed and survived and taken root. There's also the possibility that life was on Mars first and it came the other way. So now that doesn't mean that life on Earth and Mars are completely connected, although it may have gone back and forth. It's been primarily isolated through deep, deep time. And so it will be tremendously beneficial to science. It'll just be the most amazing science ever to find life on Mars. Although it may be related to Earth life, it's been isolated for so long, evolving in a separate environment, that it's going to give us a tremendous boost in our understanding about biology. So I think it's a pretty good bet that we could find life on Mars. Now, with this news that there could be liquid water near the surface, perhaps seasonally, perhaps perennially, we don't know, perhaps in just pockets or regionally. It could be that there's life near the surface, and so it may be pretty easy for astronauts to dig down in and get samples of the wet Earth, not Earth, but wet Martian soil, and there may be microbes in it now that we know where to look.
Do you think there's a chance that there may be some life a little bit more complex than just microbes, like something we can actually see with our naked eye?
I would give that a much lower probability, because here on the Earth, we didn't have much more than microbes for billions of years, and it was only something like 600 and something million years ago that more complex life forms came into the picture. So apparently it took a long, long time of just simple life on the Earth before the more advanced ones could exist. So Mars didn't have the benefit of a warm and wet environment persistently for such a long time. So I would give that a lower probability. Now, is it possible there could be more advanced life under the surface? Yeah, I guess you can't rule that out. I think that could be a possibility.
Very interesting. Where else do you think the chance of life is beyond Mars? I mean, I know Europa's been talked about a lot. Titan, those places are pretty interesting too, huh?
Yeah, it turns out that there are several moons around the gas giants and the ice giants in the outer solar system that have subsurface oceans, and these moons are kept warm by tidal heating, by the tidal forces with the giant planet that they orbit. The tidal forces warm the interior of the moon and keep the oceans from freezing solid. Now, there could also be an ocean, a subsurface ocean, in such an unlikely place as Pluto.
Wow.
New Horizons spacecraft was going to capture evidence that may tell us if there's a subsurface ocean that is still liquid. We don't have any published results on that yet. I'm still waiting with bated breath to hear. But the thinking is that the chemistry of the water could have kept it warm, could have kept it liquid, even though it's very cool out there. There may be enough radioactive material in the planet that's decaying and providing just enough warmth. So, who knows? There could be more oceans out there than we've discovered so far.
New Horizons, I think that really that blew away NASA, didn't it? Because I mean, when I think of Pluto growing up, I think of when I was growing up, we learned about Pluto, and they called it a planet still when I was in school. I just envisioned just a ball of frozen ice out there. I mean, that's a fascinating world, man. Just a little flyby we had. Wow.
Yeah, well, I think Alan Stern said it the best. He's the head of the Pluto mission. He was the driving force, one of the driving forces, probably the key driving force from its conception more than a decade ago. And Alan said this. He said that if an artist had drawn a picture of Pluto and said, "Here is my conception of what Pluto looks like," Alan would have said, "That's just over the top. It's just too wild." And yet there it is. So
yeah, man.
the people who were most focused on Pluto, the people who most loved it, and who are really hoping to find an active, amazing, dynamic world, even they were blown away by how active, how geologically diverse, how just utterly crazy it is.
I mean, dare we say it's as, if not more interesting than Mars? I mean, it's got mountain ranges. It's a beautiful planet. It's just so much more than I thought it was going to be.
Well, I don't want to compare the planets.
Yeah, true.
They're both very interesting.
Yeah.
Mars, of course, has polar caps, and now it's got liquid water on the surface.
That's true, too.
The surface. So I don't want to compare which one is more interesting. I think it's like my children. I love them each. They each call forth from my heart love that belongs to them alone. And I think Pluto calls for our attention and our interest because of what it is, and Mars calls for our attention and interest because of what it is.
Yeah.
And and I think we can love them both with the love that only they get to claim. But Pluto. I was in tears during the flyby when those pictures were going back. I was really feeling tears welling up.
Yeah.
And even last week with the new round of pictures, I felt that again. It's been just overwhelming how amazing that world is. And by the way, I call it a planet.
Yeah, I'm glad you do.
There are a lot of people who call it a planet still.
I'm glad you do, because I really see that as a planet. And the new pictures are they just keep getting better and better. Those new ones just blew me away, man. Just unbelievable how diverse and in detail these new photos show of it.
Yeah, well, here's a couple of the things that I'm waiting to hear about. In the latest pictures, there was what looks like an iced-over lake in the middle of the mountains. It's just completely surrounded by mountains, and there it is right in the middle. It's a white lake that's frozen flat.
Oh, man.
And I want to know, how does a lake form in a world where it's always too cold for liquid water or liquids on the surface? What processes formed a sheet of ice that was so flat right there in the middle of the mountains with a nice, precise shoreline?
Oh, man.
And then another thing I want to find out about, there was a location along the edge. Of course, there's the Sputnik Planum, which is part of the Great Big Heart, the Humba Regi. That's a gigantic glacier sheet, and the edges of the glacier, where the glaciers are flowing up into the mountains, I noticed there was a region where the mountains were sharp, knife-edged, long, sharp, knife-edged peaks along the tops of the mountains. And if you saw that on Earth, you would say that was formed by glaciers that had carved the tops of the mountains, because the glaciers were that high, and they were just carving down and formed a cirque in the mountains where it's not just a point at the top of the mountains, it's a long, sharp knife edge. And there were some mountains on Pluto that were just like that, and they were on the edge of the glacier, but these mountains are like as tall as the Rocky Mountains. They're that high above the glacier. So how did the glacier get that high up to carve the tops of those mountains, if indeed that's what happened?
Oh, man.
Well, it may be that the glacier was pushed, shoved uphill to shove up against the mountains, or it could be that some other process has been causing the mountains to be shaped that way. But I'm fascinated by that question. I can't wait to hear more about it.
Let's get that data in, man. You're getting me all excited over here about getting some more data back. Now, I noticed the last photo I saw, that really just mesmerizing photo. Did you see the picture where it shows the haze of the atmosphere? Did you see that one?
Yeah, I did.
Is there more atmosphere there than we thought? Is it got more of an atmosphere?
No, it doesn't have a thicker atmosphere than we really thought. But and I have to apologize. I'm not an atmospheric scientist,
right,
and it's really outside my field. But I think everybody was stunned by the stratification in the atmosphere, there wasn't just one dust layer. There was layer upon layer upon layer, and there seemed to be a lot more structure than we anticipated. And so once again, it blew our socks off.
Last thing before I let you go, there's now talk, and then seems like there's some momentum building about a Europa mission. How do you feel? Do you think we'll get something towards Europa soon?
I do. Yeah. I would really love to see a lander, not just a flyby mission. I think the easiest thing would be, and I think this is the going-in plan, to put a spacecraft in orbit around Jupiter, and it will repeatedly fly by Europa. And by flying by judiciously, you can eventually get a close look at most of Europa, most of its surface. But it would be so much more exciting and so much better payback for science if we could actually land on Europa and rove around and drill into the ice and study the chemistry by more direct methods.
Yeah.
There was a call for proposals by NASA a while back, and I think it was called the Homesteader Program, where they're asking people to develop technologies that will help these future missions. And one of the technologies they're asking for was the ability to rove on these outer moons like Europa. They listed several of the problems, several of the challenges of trying to rove there. For one thing, you may have to drive on hard ice, and then you may have to drive through fluffy snow. You may have to cross crevasses, which are crevices, cracks in glacier. You may come upon a cliff, and you've got to get down the cliff. And there's the possibility of these features that are called penitentes. They're spikes of ice that form. If you have seen an anti-tank, a field of anti-tank structures where they've got spikes sticking up in the field so that a tank can't drive through it, that's what they look like to my eyes. Just a field of maybe 2-meter tall spikes of ice. And so how do you rove through that? They're too closely spaced to drive through it. So they said in this call for proposals that the problem with flying vehicles, if you think you're going to fly over all these features, hop over the snow, hop over the crevasses, hop down the cliffs, and hop over the penitentes, well, the problem then is you run out of fuel. And once you run out of fuel in your hopper, then the mission's over. And so they were asking for technologies to solve these problems so that we can have better roving on the surface of Europa. So our team did submit a proposal on that. We haven't heard back yet if we're going to get funding on it. But what I wanted to tell your audience is that shows that NASA is actually working on technologies to eventually put rovers on the surface of Europa and other icy worlds.
Man, very exciting. Well, look, man, I really, really, really appreciate you coming on board, especially on short notice after this huge announcement. I know you guys are in demand for people to want to talk to you. So thanks. I really want to get you back on because there's so much more to talk about. We just don't have a lot of time tonight, but I'd love to get you back on sometime.
All right. Well, hey, it was my pleasure, and I will definitely come back sometime, okay?
I appreciate it, man. Thanks, Doc.
Okay, well, take care.
You too.